Hi everybody, it's Wednesday, September 23rd. So let's make sure we put that up in the left-hand corner. And today our target is adding and subtracting unlike fractions. And I know this might be a review for some, but it's okay. So let's take a look at adding first. And our big thing for this lesson is going to be common denominators. So we'll talk about how we can find those common denominators. So my example for today is going to be 2/9 plus 1/6. And I want to share with you that when I work with fractions, I like to work with them vertically because then I can show my work out to the side, and when we get into some more sophisticated problems, it gives me a lot of workspace. So I know that 9 and 6 have to be related to each other because they're multiples of 3, but they don't work perfectly with each other. So I'm going to take these over on the side, and when I'm finding my common denominators, I like to look at the biggest number first, and I just start listing them out. And I could keep going, ... But I know that 6 can go into 18 because I have my times tables quickly thought about. So I know if I did 6 and the next one would be 12 and then 18, I can stop there because that's going to be my least common multiple. Okay. And that makes my life easier if I go with the least common because then I don't have to reduce as much. So I know that my fraction is going to be 18 on the bottom, and I'm going to put that there, and I always want to have my equal sign because I know that I'm going to look for an equivalent fraction. So when I think about that 9, it's just times 2 to get to 18. So I'm going to put a little note here, times 2. And I know that I'm going to do times 2 on the top as well. So 2 times 2 is 4. And I know that 2/9 could also be 4/18. That makes sense to me. And then I look at the 6, and I know that I went times 1, times 2, times 3. And so I'm going to do the same thing on the top. So 1 times 3 is 3, and that seems very reasonable. So now I have my two fractions with a like common or a like denominator. I could just add from the bottom or add the tops, 7, and my denominator is going to stay exactly the same because those don't change when we're adding or subtracting. And then I'm going to ask myself, can I simplify this? And I'm going to say no because that 7 is a tricky little one unless it works perfectly with the denominator. So in this problem, it's no. This is my answer. If we looked at a subtraction example, let's do 8/20, and we're going to subtract 1/4. And I like this one. It's nice and neat because I know 4 can go into 20 already. So I get to keep that denominator. I love when I only have to change one denominator. So this gets to just bump over. And even though I know I'm saying the same thing, it just helps me to keep it all in a line. 4 times 5 gives me 20. So I'm going to do the same thing on the top. 1 times 5 is 5. Now I'm subtracting, so I'm going to do 8 minus 5 is 3, and my denominator will stay the same as 20. Can I simplify that? I've got that darn 3, and unless it works perfectly on the bottom, no. So this is my answer. All right, so make sure that you show your work. Ask yourself if you can simplify, and you should be golden.